Hi guys, this is the new unit. We're going to be looking at something called rotational motion. So up until now, we've been treating everything as if it were a point or a shape, but we would find its center of mass and then pretend it acted like a point. So what we're going to do is we're going to be taking a look at why or what are some types of rotating objects and how they are important in society. So I'm going to give you a couple of examples that you want to probably write down. You'll see it later on a test. So generators, um, helicopter blades, electric motors, circular saws, vacuum cleaners, swivel chairs, curve balls thrown by baseball pitchers, truck tires, car tires. These are all examples of objects that are in rotational motion. So what I'm going to do for you is just draw a picture of something that is in rotational motion. You might be able to get a better idea of what this looks like through the notes because, as you know, that I'm not an art teacher, but I'm a physics teacher. So here's my best rendition of rotational motion. So you've got a picture here of an object that's circular, and this circular object has it's not so bad actually, has an axis running through it like this. Okay, and so this body, whatever this is, can be said to be rotating about this axis. And a little cool tip that you want to maybe either look up or be able to regurgitate at some point is that whenever you throw something, let's say I were to throw something at somebody like a ball or a bat or something like that, it would always rotate about its center. This is called the center of mass. So let's look at a circle and let's label some parts here. So if I draw a circle, okay, something like this. Okay, here is the center of mass of the circle. And I'm going to put some labels here. So there's going to be a line going out here, and this is to signify the radius. Okay, and again, in a circle, the radius is the same. So put another R here. And I'm going to call this angle, and I'm going to call this point B and point A. Okay, this S here is our distance from here to here. Okay, so this is the basic diagram of a circle. So we'll say it starts at point A and then rotates to point B. So I'm going to give you guys a relationship as to how we define this angle here. Okay, this angle can be defined using a combination of the radius and the S, the distance that it swings around. So let's just take a peek at it. Okay, I'm going to give you guys a formula. Angle, I'm going to write it a little bit larger, is equal to the S. You can think of the S being like the distance swept. I just think distance swept for S over the radius. Okay, so if I wanted to calculate the angle, I could take the distance swept and divide it by the radius. A little background theory on this is the fact that if we're angles now, we're not going to be using degrees. We're going to be using something called radians. And in your calculator, you want to make sure that you are switching back and forth between the right units, angles versus radians. Angles would be something called degrees, and radians would be something called RAD on the calculator. Okay, so S can be written, expressed a little bit differently. We can call this 2 pi r, okay, and then this is over r. And if we take a full 360 degrees, we can say that a full 360 degrees is equal to 2 pi times radians. So I'm just going to get you guys the simple derivation here. 1 radian, okay, is equal to 360 degrees divided by 2 pi, which ends up being 1 radian is about 57.3 degrees. Okay, just to give you the idea of the size of a radian. Okay, let's put this into practice. I've got a situation for you. You've got a circle. Okay, we'll draw the radius here, and then I'll give you an arc length. This is radius. Radius. I'll give you an arc length swept of S. And so I'm going to give you the radius of this circle, R, is 5 meters. I'm also going to give you the S, the arc length of 0.25 meters. So if we go to solve for this, we should be able to get the angle in radians. Okay, so look, we've got 0.25 here and 5 meters here. So the angle is equivalent to S over R, which is 0.25 meters over 5.0 meters. And it turns out, just a little bit of calculator work here, that the answer is 0.05, we'll call it rad or radians. Now, if we wanted to convert this to degrees, we could very easily do that, because we know that 1 radian equals 57.3 degrees. So to go from radians to degrees, okay, all we would have to do is 0.05 radians. When I get to degrees, okay, radians is going to be divided out. This is a division sign and this is a multiplication sign. We know that 57.3 degrees is 1 radian. So all I would do is I'd just take this and multiply it by this. So 0.05 times 57.3, and my answer would be 2.9 degrees. Okay, so just to get it back to our familiar terms of degrees. So that'll be it for the mini lesson. I'm going to give you guys a homework set to practice with these conversions and such. Okay, thank you. Have a good day.